Hello everyone, welcome to Vishesh Educational Videos. In this video, I am explaining about three different types of APIs of Unix system programming, that is Access, CHMOD and FCHMOD APIs. If you are not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon. And please don't forget to like the video and please don't forget to share the video with your friends. So let me begin the explanation of these three APIs: Access, CHMOD, FCHMOD. So the Access system call, the Access API checks the existence and access permissions of a user to a named file. In simple words, the Access system call is going to check the permissions of a user if we want to access some file. So first it should check whether a user has a proper privilege to access that particular file. So I can use a access system call for that purpose. The prototype of access function is, you can see here the argument of that access function, two arguments are there here. The first argument is a path name and the second one is a flag. Why I need a path name? So if I want to check the permissions of a user, right? If you want to access a particular file, I need a path name, right? First, I need a path name of that file, then I can check whether a user has a particular permission or not. And the second one is the flag argument, right? So if this prototype, right, is success, it is going to return 0. If it is a success execution, it is going to return 0. If this prototype is going to fail, means it will return -1. On success it returns 0, on failure it returns -1. So you know that the first argument is a path name and the second argument is a flag. So flag argument contains 2 or more bit flags. So you can see here, so that flag argument contain FOK, ROK, WOK or XOK. So in that argument I can use FOK or ROK, WOK or XOK. Based on that I can check the access permission of a user to that particular file. So if it is FOK, means checks whether the named file exists. So it will check whether the named file exists or not. So ROK means text, it is going to test for read permission. It is going to test whether the particular user has a read permission for that particular file that is going to access. The next is WOK, that is it is going to test for write permission. So and XOK means it is going to test for execute permission, right? So the flag argument value to an access call is composed by bitwise OR. That means if you want to check this permissions, two permissions are simultaneously. For example, you want to check both read permission and write permission simultaneously for a particular user. Then how you are going to do that means you are going to use a bitwise OR operator, right? You can see here. So here RC example, here you can see here RC means read count. So you are using a access prototype here. So you are going to check the permission for a particular file called usp.txt. That usp file, that is a text file, it present in the folder called Divya, and the Divya folder is present in the user folder, right? So I am going to check the permission. What is the permission that is given to that particular file USP. So to check that, you can see there I am checking two types of permissions, that is a read permission and write permission. To check two different permissions for a single file, how I am doing it, right? How I am doing it? I am doing it by using a OR operator. I am combining both the permissions using a OR operator, right? So you can see the example here. So example to check whether the file exists. How we are going to do it means you are using a if statement here. you're using a along inside the if statement you are using a access prototype. So you are checking the where the file usb.txt whether it exists or not. So you can see there you are using a flag bit flag FOK. It's going to check whether the named file exists or not. It's going to check whether the usb.txt exists or not, right? If it is if it returns -1, the access prototype returns -1. What does it mean? I told you, if it is returns -1, it's a failure. That's why. What is the printf statement? If this access function returns -1, it is going to print file does not exist. Otherwise, if it's returned 0 means it will print file exists. So always if it returns 0, you should know that it is successful. So that's why it's going to print file exists. Getting, guys? Hope you're understanding. Suppose if you have any doubts, please post your doubts in the comment section. Next, the next is CHMOD and FCHMOD functions. The CHMOD and FCHMOD function, right, are used to change file access permission. You can change the file access permission. In the previous case, you can check the permissions, but using the CHMOD and FCHMOD, you can change the access permission. You can change the access permissions for owner of the file and also group of the file and also others as well, right? You can set user ID, group ID also. If you want, you can change that permissions, access permissions using CHMOD and FCHMOD, right? And one more important thing, a process must have the effective user ID of either the super user or owner of the file, obviously. So this is the main thing. The process, if it wants to access a file, so the process must have the user ID, right? User ID of the owner of the file. So these are the prototypes. What are the prototypes for CHMOD and CHMOD? You can see here CHMOD and FCHMOD. For CHMOD, the argument is path name and the second argument is a flag, and for FCHMOD, the first argument is a file descriptor and the second argument is a flag. You can see there path name is mainly used to find the particular file. If you want to check the access permission, you need a file first. That's why CHMOD is going to use the path name to find the file, and FCHMOD is going to find the file using the file descriptor, right? So what a flag contains, right? You can see here, the path name argument of a CHMOD is the path name of the file, whereas the file descriptor argument of the FCHMOD is the file descriptor of the file. You know that already. The CHMOD function operates on the specified file. Remember this. The CHMOD function is going to operate on a file, whereas the FCHMOD operate on a file that has already been opened. Difference, understood the difference? The CHMOD function operates on the specified file, but FCHMOD function operates on a file that has already been opened. So to change the permission bits of a file, the effective user ID of the process must be equal to the owner ID. The user ID should be equal to the owner ID, otherwise you can't change the permission. Just remember that. It should know that the user trying to change the permission is the owner. If it's the owner, then only you can change it. Or the process must have super user permissions. Obviously, if it has administrative privileges, it can change the permissions. The mode is specified as, you can see there. So for CHMOD and FCHMOD, again it is using a flag. The mode is specified. So mode can be, I told you, right? Read permission, write permission, or execute permission. So that mode remains the same for CHMOD and FCHMOD also. You can change the permission, right? You can change the permission of the file to read or to write by using this CHMOD or FCHMOD. You can change from write to read or write to read to write or write to execute or read to execute, like that. You can change any permissions, right? You can see there the mode is specified as the bitwise R of the constant shown below, right? So see, these are the extra modes what I can use in CHMOD and FCHMOD along with the read permission and the write permission also. These are some extra modes I can use to change the permissions for a particular file. See, you can see there, if we say s underscore is uid means you can set the user id on execution. S underscore is gid means you can change the group id on execution, right? So you can see there, s underscore is vtx means you can write a saved text, sticky bit. You can change that, right? If it is s underscore irwxu means you can change the read permission, write permission, execute permission by the owner, right? So if a mode is s underscore ir usr means it is a permission read by user. If s underscore iwusr means write by user. If s underscore ixusr means execute by user. So you can specify these modes in any one of this CHMOD and FCHMOD. You can change, right? You can change. See, in the same way, for a group also, read, write and execute applies. First, I explained the read permission, write permission, execute permission with respect to user. In the same way, read, write, execute applies to group also. In the same way, read, write applies to others also. Right? You can see that. So that's it, guys. Hope you understood the concept. Suppose if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.